Open System Interconnect, OSI. We saw about Open System Interconnect. We learned that it is of 7 functions. To understand, it has been explained to us as 7 layers. Open System Interconnect. Now, this is a standard proposed by ISO. So it's a reflection. It looks like a reflection, right? IS. Anyway, this is different. That is different. This is the standardization organization for standardization. Industry organization for standardization. That is the organization who prescribed this internet standard called OSI, Open System Interconnect. As I said earlier, this is an idea. I did not use the word idea. I said this is a model. This is a reference model, meaning if you want to manufacture, if you want to design any network device, anything, it can be a router, it can be a switch, or it can be a computer. Now your computer is little old. You decided to design your own computer because you are an engineer. Now you can do it very well, but in that, make sure these 7 functions can be carried out. If the 7 functions is carried out, then your device can become the part of network. Your device can communicate over the internet. So your device can become part of internet only if the 7 functions are carried out. சமைக்க தெரிஞ்சாதானே சமையல்காரன். So if your device cannot carry out these 7 functions, it cannot be a network device. It may be a computer for doing some mathematical calculation, but it cannot be used for networking. சுடுதண்ணி மட்டுமே செய்ய தெரிஞ்சுக்கிட்டு எனக்கு சமைக்க தெரியும்னு சொல்ற மாதிரி அது. If the computer cannot carry out the 7 functions, 7 layer of function, then it cannot communicate to any other device because the other devices follows the standard, these functions. So when both does the same thing, only then they both can understand each other. If I want to say A, I write like this. But if the other computer A means this, they don't understand. I say this one, the other computer say this one, they don't understand each other. Just for example, I wrote. So if my computer is for A, if my computer will say this, the other computer should also say this. Should also say A means this. Only then they understand each other. This we saw in the previous class. It's a standard. Open System Interconnect is a standard. The 7 functions we learned as 7 layers. The top layer is layer 7. It won't start from layer 1. Layer 1 will be at the bottom. That layer 1 need to be in the bottom. Layer 7 is called as application layer. This application layer has got some function to carry. What is that? It creates an environment, it provides an environment where you can run some service. For example, this Google Chat, which I'm using to Google Hangout, Google Chat, which I'm using to conduct the class, is an application layer. Without that application, I cannot initiate the connection between your laptop and my laptop. That's an application, and it has provided me an environment where I can make a call and connect to you like this. That application has created an environment in your laptop to join the call. It's an application layer. See, this word, MS Word, it's an application, but it's not a network application. So this won't be coming under application layer. This Word, Microsoft Word won't come under application layer, even though it's an application. So in networking, to do network, we have some application. Example, this Google Hangout, this chat. You understand what I mean? Application layer. You give some examples for application layer. Yeah. For doing any network communication, we have various applications. One example yeah, Zoom is one application. Exactly. Zoom is there. Okay. That is nice. Yes. What about Putty? Have you heard about Putty? Actually, it is Putty. Oh no, it's going somewhere. Yeah. Even this one is an application. We can use this application to do SSH, Telnet. These are all what? Network services, right? So any application that provides you network service, they come under this application layer. They provide an environment. So first thing is you need an application. You need an application layer in order to communicate to someone remote. As I said earlier, five-star hotel, you don't need to say uh, there may be a swimming pool, or if you are running a five-star hotel, you don't need to tell your customer, we got a swimming pool. They know. Five-star means according to the standard, there should be a swimming pool. Likewise, the device should have an application in order to communicate. It's an application layer. Now, we got different type of applications because you send different type of traffic. I just told you putty is one application. But with that putty, can I do voice call? So for voice call, I have Zoom, I have Teams. For Telnet and SSH, I have putty. Likewise, we have various applications. So we send a mail, we receive mail. That is different application. So all these applications generate different type of traffic. They're all not same traffic. Some are mail, some are voice, some are video packets. Some generate telnet traffic, some generate SSH traffic. So we got different varieties of traffics generated from different applications. that need to be encoded properly, that need to be presented properly. That is why it is called as presentation layer. See, for you and me, we understand very well mail. We understand telnet. We understand SSH. But the wire that carries your data, or the Wi-Fi signal that carries your data, they do not know anything. They know only zeros and ones, isn't it? Bits and bytes. Our data are carried in the form of bits and bytes. They simply go in 0 and 1. But when it comes to your computer, it exactly opens in the chat tool, the chat application. How is that possible? Because my laptop have presented my data into zeros and bytes in such a way that when your laptop receives, it will understand that this is a voice, this is a video traffic. This need to be opened with Google Hangout or Teams. You see, that's why it is called as presentation layer. For example, if you buy a machine, the manufacturer is manufacturing the machine. They sell it to us with a manual. If there is no manual, for example, a robot, till today, no one have got purchased robot. According to me, no one has purchased robot for uh, for for um, for bringing for making coffee and bringing it to me. No one has got a robot so far, according to me. There are robots to sweep the floor, but let us assume first man in the world, you are purchasing a robot for making coffee, bringing it to your desk every morning and evening. Now, the manufacturer would have manufactured in his idea, but how do I know that the robot will work like this? How do I know where to start the robot, how to start the robot, how to make my robot to work for me? So there is a need for some presentation, meaning the manufacturer should write a note. He has to write a note and tell that this is how this will function. If you want to make this robot to work, you need to say hi or something like that. Hi. Then it will immediately start listening. If you say some other word, it may not listen to you. If you start with, I have an iPad. If you say hi Siri, then it will wake up. Okay, something the owner is talking. See, that's the procedure to provoke that application. Hi Siri. Likewise, when you send a mail, someone should write a note saying this is a mail packet so that the receiver will open with the application that supports mail. Likewise, when I do telnet, someone should write a note. This is these zeros and ones, these list of bytes or telnet traffic. That noting, that mentioning of what the traffic is done by this application layer. The application layer only does, sorry, what I'm saying, presentation layer. This presentation layer only writes a note. That is what called as encoding. It encodes in such a way that the machines, the network devices can understand what packet it is. For you and me, we know what is telnet, English word. We know telnet means terminal emulation. We want to emulate a remote device here. That is telnet. We understand, but how network understands, how the machines will understand. So someone should interpret in the machine language so that machine will carry the packet with that note. It's a telnet. And your machine, when it receives the packet, it reads the note. It's a telnet. Okay, if it's a telnet, then I need to open using this particular command line console. It opens for you. So presentation layer is very important. You need to present it with the right uh, note to the network. Is that clear? Presentation layer. Now, see how meaningfully they have given name for these functions. See this layer and all you cannot see with your eyes. Can you see presentation layer? No. These are all ideas. Using this, someone should develop their device in order to interact in the internet. That's why it is open system, regardless of vendor, regardless of the hardware configuration. Devices communicate. A Pentium device can communicate to Intel, whatever, 7 or 5 or 5, whatever. Various process versions have come, various motherboard makers come, Celeron, Pentium, AMD. So they all interact. It is because these 7 layers are strictly followed in any profile, hardware profile. Now, after the presentation layer comes session layer. Session layer. You see, the session is very important. At a given point, my laptop can do 1,000 different works. Any device can do multiple tasks same time. As I am talking to you, this is not the only job my laptop is doing. My laptop is recording. My laptop is sending you voice traffic. My laptop is also sending video traffic. My laptop is doing various other things like checking updates, keeping track of the time, and also keeping the connection alive. This Google Chat connection that we are using to talk, the Google Hangout, the Teams, it is keeping it alive. It is not getting disconnected often. So there are a lot of traffics going in between my laptop to the network and to your laptop. A lot of things going on, not just one job, there are many jobs. When many jobs are carried out, the session is very important. Which job at what time should go out? If all try to go out at the same time, then congestion, then problem. Even the CPU cannot be utilized. You got a CPU. If all the job that's currently running in my laptop, let's say 10 different job my laptop is doing now, if all 10 go at the same time to the CPU and also at the same time it wants to go out, is that possible? No. So there's a time frame. There should be a time frame given for each job so that there won't be conflict between one job and the other. Session layer takes care of it. You understand the session now? The time. Session layer, without this, there will be conflict between the jobs. Now, I'll just give you one simple example. I know you. I know very well you understood, but still, one small example. When you're downloading a file, as soon as you start downloading, it shows you estimation time. How is it possible? Because it is maintaining session. It knows that your laptop knows that this is my capacity. If I run in this speed, it will take this much time for this big file to get downloaded. It can calculate. And if there is a network disconnection in the middle, the session layer immediately makes a checkpoint. Now half an hour out of 1 hour, half an hour download is over. It will make a checkpoint. This much download over. And when the internet comes back, it will start again. It will say estimated time half an hour, which means it is continuing from where it left, which also shows that the session layer is well maintained. If no session layer, then you need to start from the beginning. If no session layer, then you cannot make checkpoint and you cannot continue from where you left. Session layer is important for communication. See, if both the people are shouting in the phone, communication won't happen. There is need for a session layer. When I speak, that's a session given for me. The other person should not speak. Have to listen. When the other person speak, that is a session time given for him to speak. I have to listen. Only then the communication will happen. Likewise, in networking also, there is a need for a time frame to be maintained to avoid conflicts between services. As I said, there can be multiple services running at the same time. So someone should neatly take care of the session to avoid conflict. Even in doctor, if you are going to see doctors, they give you time. There are some clinics where people go and wait in queue, but most of the rich doctors, they don't want a crowd in their house. Yeah, on demand only. You should ask, get an appointment. Only when they say, okay, come at the 7:15, then only we can go at 7:15. Otherwise, we cannot. So when we follow that session, there won't be conflict. There won't be conflict. So when you go there, there won't be any other patient. You can easily finish your visit and come back. No waiting time. And we won't be disturbance for others as well. So session, maintaining time, setting time frame for going and coming is important. That is taken care by session layer. Next is the transport layer. Transport layer, see, as the word says, transport, this layer is responsible for transportation of our data. You see, my laptop speed, my laptop RAM size, CPU size, motherboard capacity, the cache memories, and then my network, very important. My network bandwidth is not same with your network bandwidth. So my laptop and your laptop cannot do same type of transportation. According to the capacity of my medium that I have, my wire, my transport layer will decide how big the packet should be. How many packets, how big. According to your laptop capacity, your laptop will decide how big the packet size need to be. Transport layer is taking all those things and segmenting your big data into pieces so that it can be easily carried. That is the job of transportation layer. Transport layer needs to do transportation. When you have 50 kg of gold, can you give this 50 kg of gold to 5-year-old child to carry? No. Maybe maximum of 2 kg you can give to a 5-year-old child. If the child is interested in helping you, you can give 2 kg. Easily the child will carry. So if you cannot carry and you want some help from children, and all the children are 5-year-old, now how many children you need? 25 children. You need 25 children. This is what transport layer do. It takes your big data and chops the data into small pieces so that it can be carried easily by your network. According to the capacity of your device and the capacity of the network, this segmenting is done here. So your data from here to here is called as data only. But when it comes to this place, it is called a segment. Because it does segmentation. Our data is already segmented now, broken into multiple pieces. You see, if it is broken into multiple pieces for easy transportation, then this need to be numbered. It needs to be numbered, saying first piece and second piece. It needs to be numbered so that when you receive this packet, you can rearrange in order. The data can be rearranged. If this number is not there, what will happen? Sometime you will put 4 in the beginning, 6 next, then problem. On the receiving side, if the 6 packet is in the first, 4 packet in the, then you won't get the meaning of the data. You understand, right? If your data is jumbled, problem. So you want to have the exact meaning. So it needs to be rearranged on the receiving side to get the same data, not the jumbled one. See, internet is a big web, no? There are multiple paths to reach your laptop. So sometimes this packet will come, this segment will come to you first, and then this will come, and then this will come, and then this will come. So as it comes, if you keep arranging, then problem. You need to arrange according to the sequence number. So we need what? Sequence number. So transport layer not only segments the data, it also puts the sequence number so that it can be transported and rearranged on the other side and get the same meaning. Yeah. So transport layer is good for it is responsible for transportation. Transport layer is responsible for transportation. You can easily transport, you see, if you can do segmenting, if you can do sequencing very well, transportation can be done. Now, there are other jobs that transport layer does. Transport layer also decides what sort of transport we are going to do. Are we going to do transport with acknowledgement or without acknowledgement? See, early days, we used to have a postcard. We used to write letter in a card, postcard, and we used to send. My last time that I saw this is when I was in 12th standard. The yellow color card, postcard. Have you seen? Okay. Do we have it now? We don't have. Okay. So this postcard came in two ways, two types. One is 25 paise postcard. Another one is 15 paise postcard. 15 paise. 25 paise, 15 paise. Later, I think it became 45 paise, something like that. I remember this 15 paise and 25 paise. This 15 paise is one way communication. You write letter, you post it, I'll receive it. But how do you know that I received it? You will not know. I might have received, I might have not received. But this 25 paise postcard is no different. When you write letter to me, that card will also have another card which you should not use. It will be fitted to that card. There will be two cards like this. Whereas this one will be only the upper part. This is 15 paise. You write letter, I receive it. Sometimes I may not receive it also. You don't have any proof. But this is not like that. You write letter and you send it to me. When I receive to the postman, I need to sign here and I need to write anything that I want to write. And then only this portion the postman will give me. Now this will be sent back to you by the postman. And when you receive, you can confirm that I received the upper part. You see, you got an acknowledgement saying that Jay has received your letter, your postcard. So this is also one way of transporting data. This is also another way of transporting data. Depending on what application we pick here, one of this will be used. For example, I'm using this Microsoft Team or whatever we call it as Google Chat. This one will use this one, this 15 pies, no acknowledgement. This is what called as UDP way of transportation. UDP stands for User Datagram Protocol. User not telegram, datagram protocol. User datagram protocol. User datagram protocol is like a postcard without acknowledgement. Whereas when I telnet or when I send a file, that will follow this procedure. It is TCP based. Transmission Control Protocol. Transmission You see, which one to follow depends on what application you use. If you are using some time sensitive traffic, like what I'm talking now, when I talk simultaneously, you should listen. So I cannot use TCP, only UDP, because I want fast delivery of traffic. If you use acknowledgement and wait for acknowledgement to send the other traffic, then problem. It will be delayed. UDP is, I don't expect any acknowledgement. I keep talking, hoping that you are there listening. Your computer is keep on receiving the packet and your speaker is talking to your ears as I am speaking from here. I cannot use TCP. What will happen if I use TCP? Packet will come and next packet won't come until I get the acknowledgement for the packet you received. I repeat, I will not send the second packet until I receive your acknowledgement for the previous packet. Then there will be a break in the voice. You understand? UDP cannot be used. Are you there? You see? This is also an acknowledgement. See, our communication stopped because if I expect acknowledgement, asking are you there, and until you say yes, I cannot speak the next word. That is the problem with UDP. But TCP is not like that. Sorry, that's the problem with TCP. TCP cannot send the next traffic until it gets the acknowledgement for the previous traffic. But UDP is not like that. UDP will not ask, are you there? Did you receive? Nothing like that. It will keep on sending. So wherever we want fast communication, wherever we want uninterrupted, wherever we want streaming traffic, voice, video, we will see UDP used. UDP is what? Used. I can show you that. I can show you right now. We have a tool called Wireshark. We have a tool called Wireshark. With that Wireshark tool, I can show you. Here it is. Now, as we are talking, a lot of UDP traffic will be going out from my laptop. My laptop, Ethernet wire. You see, there's a lot. You see, a lot of UDP here in the middle. This is live network. This is the voice that I'm talking to you. There is also some RTP protocol. RTP stands for real-time protocol. That is also why a voice. Or show me only RTP. You see? No? Okay. Clear. Then what it is? If it is not RTP. Okay, RTCP. RTCP. Okay, this is an RTCP packet. What is RTCP? It's a voice, actually, voice protocol. You see? That also uses what? UDP. You see, user datagram protocol? And it's a real-time transport control protocol, RTCP. Real-time transport control. They don't need any acknowledgement. They're very fast, voice traffic. These are all my packets, which my voice are going out, right? And I'm also getting your voice from your side when you speak. So UDP is one type of communication. TCP is another type of communication. Which one to use is determined by this guy, TCP, transport layer. transport layer decides which one to follow. More about this TCP and UDP, I'll be explaining you in the next class. We will be learning TCP UDP differences, and there's something called three-way handshake in TCP. We'll talk about those things in our next class. Now, the next layer is what called as network layer. So after the packet got small segmented pieces, the packet comes to the network layer. This is where the source and destination IP addresses are attached to each packet. And the segment now gets another name called packets. Once the IP address is assigned to the segment, each segment is now a packet. So what is given here is source, from where the packet is coming, and the destination to where the packet needs to go. IP address, for example, 10.0.0.1. From here, the packet is going to 40.0.0.1. So those informations are added to the packet, where the packet needs to go, what IP address the destination is in. More about this we'll talk later. And then layer 2 is called as data link layer. In here we are going to have source and destination, another address called MAC address. MAC, media access control address. MAC address or machine address. Every laptop has got a MAC address. Every router has got MAC addresses. Every interface of a router will have a MAC address. So MAC address is like your fingerprint. Your fingerprint is unique. No one on earth has got your fingerprint. See how great our God is. Your fingerprint is not with anyone. It's very unique for you. See how special you are. I'm special. You are special. This fingerprint is so unique. No one on earth has got this fingerprint. Even in future, no one is going to come with your fingerprint. Even in the past, no one had got this fingerprint. So unique. Everyone on earth is unique. That's how God is created. But do I know your fingerprint? No. I know your name, Prem. Isn't it? Likewise. This IP address only people will know. No one will be interested in learning your MAC address, your laptop MAC address, my laptop, but they are still used. Automatically they are added. All right? For communication, they are added. Without the fingerprint, you cannot get your Aadhaar card. Without your fingerprint, you cannot get your passport. Definitely, it is still added for your identification. That is very important. More than your name, your fingerprint is important for the passport office. You know that? So, our parent given name is not so important for them. God given identity is what the passport office focuses on. Because the name can be changed at any time, but this fingerprint cannot be changed. Wow. So great. God is very great. Okay. This data, after getting the MAC address, it is called as frames. Frames. And now, the frames now are sent over the wire. That's called physical layer. It can be wire or it can be a Wi-Fi medium. It goes in bits and bytes, isn't it? Right. So I have gone through one round of this OSI for you. We'll need to go another one round in our next class.